welcome back. Glad to have you once again here with us. So what we're going to do now is make a slight differentiation between two particular examples that sometimes confuse students and even professors at times. I'm just kidding. And it's what makes the chain rule a little bit hard and tricky for some of the math students in college, okay? But don't worry, we're going to try to do it the best way as possible, and we're even going to work out a little bit of a more complicated example so that you can see that there's nothing to be afraid of. As long as you're organized, as long as you're following the rules, you should be fine. That's pretty much my motto, as you may have figured by now. So, as you can see, we have two functions right here, one on the left side and one on the right side. Okay, the first function is sin square x, and the second function is y equals sin of x squared. Okay, they look similar, but in reality they aren't. Okay, I want you to pay close attention to where the square is, and again, always ask the function. Always ask what is happening to the variable. So let's go to the first function first. Okay, I have a variable. It's called x. So what do I do with it? X. I calculate sin, and then I square it. Okay, this is exactly the same as to say sin x, all of this squared. Okay, these two are equivalent. It's just that mathematically, the notation to do sin of x squared, they just put the 2 right here on top of the sin. Okay, but again, what is happening to the variable? I calculate sin, and then I square it. Do you see that there is a composition of functions right there? There's two functions happening, okay? First, sin of x, that's g, and then f, the square. That's the last step that I do. Okay, so we're going to label them just as we have been doing so far. This is g, and this is f. And we're going to do the chain rule on it too. Okay? If I was to find the derivative of this function, then I have g as the intern and f as the major. Again, let's do the steps one more time. I have a variable. What has happened to it? I calculate sin of it, sin of x, and after that's done, then I square it. So the square is the major, it's the last step. So that is the f, and the sin is the g. It's the minor one, okay? So what does the chain rule says about this? Well, as you may have seen up here and in the past example as well, when I have the derivative of a composition of two functions, that is, derivative of f, the major one, evaluated in g, the minor one, the intern one, times g prime, okay? This is g, this is f, so that's what we're going to do next. This is y, and y prime is going to be f, derivative of an exponent, okay? F is the major function, so how do I derivate the exponent? Forget about what it's inside, okay? I'm just going to derivate the exponent. 2 goes down, evaluated in g. What is g? Sin x, okay? And you know what? Let's do the colors again so we can keep consistent. 2 goes down, the exponent goes down, 2, evaluated g, and we use red for g, sin x, times g prime. And what is g prime? The derivative of sin times g prime, which is cos of x. And this right here is the result of the exercise. Again, derivative of a composition of two functions, g and f. f, 2 goes down, 2 minus 1 is 1, 1, evaluated in g, sin x, times g prime. G prime, the derivative of sin is cos. Okay? And there you go. This is the derivative of sin square of x. Okay? Now, let's do the second function, where we have sin of x squared. Let's ask the function what is happening to the variable. What is happening to x? Well, first of all, I square it. Then I do the sin. It's the opposite relationship. In this case, g is right here, x squared, and f is right here. Sin. Okay? I have the variable, first I square it, it's the first thing I do, and then I do the sin. That's the major thing, that's the last step. So, what is going to be the derivative of it? Well, y prime is going to be f prime, derivative of sin, cos, evaluated in g. What is g? X squared. Right? Times g prime. What is g prime? The derivative of x squared. What is the derivative of x squared? 2x. So, we can simplify this or just rearrange it so it looks a little bit more organized, and we're going to have y prime equals 2x cos x squared. And as you can see, both derivatives are different. Well, because the functions are different, okay? Remember, there is a difference between sin of x squared and sin square of x. Just like there should be a difference with, say, cos square of x and cos of x squared, or tangent square of x and tangent of x squared, okay? The difference is what happens to the variable first, okay? That is what you have to determine. And now we're going to do an example that combines both elements, because I know that that's what you're asking for. We're going to erase this, and we're going to do an example that combines both cases. And you'll see that if you're organized, if you're methodical, and if you follow the steps slowly, one at a time, you'll be able to have the grip on the chain rule 2, 3, and even 4 composition of functions. Let's say we have something like y equals 3 cos square, or let's say cube. Let's say fourth instead. Cos 4 of x 9. Something really interesting, just to spice things up a little bit, okay? We have pretty much of a mess here, right? Well, don't worry, just be organized. Let me pick up the marker that fell out. We have a variable. The first thing that we have to do is understand the priority of steps that is happening to that variable, and what are the operations that are taking place. The variable is called x. What happens to x? Well, let's list them right here on the right side of the board. We have x. The first thing that happens to x is I powered it to the 9, okay? X power to 9. Second step. Then I calculate cos of x. 3. Then I 4 the power at cos. And finally, I multiply that by 3. So as you can see, we have a composition of 3 functions right here. Exponent, cos, and power. Okay? Multiplication is just a multiplication. It's not a composition of functions. Okay? So, using our markers and our colors, we're going to be organized and do exactly what it says on the chain rule for the composition of 3 functions. Okay? Which one is h? It's the first function. It's the first step. It's the minor one, the enter one. What is the first step? X power to 9. So this is h, right here. Okay? Let's let's redraw that h. Didn't really like it. This is h. Okay? Which is g? Well, after I powered x to 9, then I do the cos. So this is g right here. Okay? And which is f? Well, after I have done the cos, then I powered it to 4. So this is f right here. Okay? And all we're going to do now is just follow the rule of f composite with g composite with h. We're going to have f prime evaluated and g evaluated on h times g prime evaluated and h times h prime. Okay? So y prime is going to be, all we are going to do is be organized. 3. Let's separate the constant. Okay? F prime derivative of an exponent, 4 goes down, right? So let's do parenthesis, 4, right? 4 goes down, cos 4 minus 1, 3, derivative of an exponent. Okay? We got rid of that. Now, f prime evaluated in g evaluated in h. So 4 cos cubed evaluated in g, which is